Hey there, gonna help you out with comparing fractions here. So when we're comparing fractions, it's all about denominators. When we have our denominators that are the same, it's gonna be easy to compare. Like let's look at this first one. We have 3/8 and 5/8. Well, these are both eighths, meaning the pieces are still the same. So if here's a poorly drawn model, that's an eighth. I have 1, 2, 3. And then here's another model. It's an eighth. I'm going to do 1, 2, 3, 4, 5. We can clearly see that since the pieces are the same size, we just look at how many is shaded. That numerator and 5 is greater than 3. Therefore, 3/8 is less than 5/8. So when the denominators are the same, we're just going to look at the numerators to see, okay, which numerator is larger, because then that tells us how many it has more of those shaded pieces. The problem will lie sometimes when we have different denominators. So we have 2/5 and 4/10. So we want to make it so they're the same denominator. Well, the question we should ask is, look at the denominator with a digit that's smaller. So we have 5 here. First, before you do anything else, think, can I create an equivalent fraction that with fifths into tenths, where it has 10 as the denominator? Can I multiply 5 by something to get 10? And the answer is yes, I could do that. So that way I could just keep 4/10 the same. I'm only going to change 2/5, and I'm going to change them into tenths. So I need to ask myself, what times 5 got me 10? Well, 5 multiplied by 2 is 10. Now, when we multiply numbers by 1, our number doesn't change. So I need to multiply my numerator by 2 as well, because that's the same thing as multiplying a number by 2 halves, and 2 halves equals 1 whole. When we multiply by 1, our number doesn't change, so multiplying the numerator and denominator both by 2 will make it so we have an equivalent fraction. 2 times 2 is 4, so looking at this, I have 4/10, 4/10. These are equal, which means then that these must be equal, because 2/5 is equal to 4/10. All right, last one we have here is going to be 1/3 and 2/8. So I have different denominators. I want to see if I can get them to the same. Look at the one with the smaller digit, thirds. Can I change 3 into 8? Is there anything I can multiply 3 by to get 8? Any whole number? No. So I need to figure out what can I change both of these denominators to so they are equivalent. Well, we could do this by finding our multiples, and we can look to see what they have in common. So let's find the first 5 multiples of 3 and the first 5 multiples of 8. So we have 3, 6, 9, 12, 15. All right, let me keep going. All right, now I'm going to do my multiples of 8. I have 8, 16, 24, 32, and then 40. I want to look to see, are there any that they share in common? I do not see any in common, which means I got to continue doing my multiples. Choose the one with the smallest number. All right, so then I get 18, and every time I do one, I'm going to look to see, is it there? Nope. All right, then I have 21. Is it there? Nope. And then I have 24. Oh, look at that. They share 24 in common, which means I could change thirds into 24ths, and I could change eighths into 24ths. Now I want to look to see, what did I multiply my denominator by to get that new denominator? 3 times what is 24? Well, we can count our multiples. This would be 3 times 1, 2, 3, 4, 5, 6, 7, 8. So we multiplied our denominator by 8. Just like before, we're going to have to multiply our numerator by the same number, so we're multiplying by something equivalent to 1. 1 multiplied by 8 gets me 8. Now I need to look to see, all right, what do I multiply 8 by to get 24? 8 times what is 24? Well, this is 8 times 1, 8 times 2, 8 times 3 is 24. So then I have 2 as my numerator. I'm going to have to multiply that as 3 as well. It needs to be the same number, so that way it's equal to 1. I'm multiplying by something equal to 1. 2 multiplied by 3 would be 6. Now I have 8 24ths versus 6 24ths. Well, 8 24ths is larger than 6 24ths. Therefore, 1/3 is larger. It's greater than 2/8. So we can work with the same denominators. When we have the same denominators, all we have to do is just look at the two numerators to figure out which one's greater or if they're equal to. All right, hope this video helps. Thank you.